Okay, what do you folks think the second one is?
You said D.
What was that?
The delta.
So if I have a large p-value, high probability, so my sample has a high probability, does that mean that the difference between my sample and mu naught is due to random chance, or that they really are different? A large p-value, does that mean that I reject H naught or don't reject H naught? Large p-value, does it mean I reject or don't reject H naught? Do not reject H naught, right? Is everybody on board? So if I do not reject H naught, is my difference between my sample and mu naught or p naught, is it due to random chance or is it really different?
It's due to random chance.
It's due to random chance. Remember, my p-value is the probability of getting my sample, assuming the mean is the mu naught, H naught is true. So if the probability is high, if my p-value is high, that means that I did not get anything unusual. That it's just due to random chance. So, folks want a minute to talk this over with their neighbors? Should I draw another picture or should I draw another picture?
I picked random chance, and I was like trying to think about why did I do that, but like I had a reason behind it, but I couldn't remember what the reason was. I need to like write down. I just read some letters. Right.
Right, so here, here's mu naught. Remember, H naught says that I'm here. If I get something in here, high p-values, not unusual values, typical p-values, then yeah, that could be totally due to random chance. Right, it's going to vary a little bit. When I get something out here, that's unusual. If I get something beyond my critical value, that's when I'm like, I got a small p-value, it's unlikely, I reject H naught, I reject H naught, yeah. And that's when my difference really is, I really am different from there, right? Here, this is just due to, my difference from mu naught is just due to random chance. So, kind of, yeah, so wrap your head around this one. This picture might be a good thing to have in your notes, maybe, something like this. Right, and I would say take a picture of it quickly because I'm going to move on in 5 seconds. Use your Zoom. All right, Quentin, go and read. Quentin?
What does a confidence interval mean?
Read the first one.
A, we are checking to see if we have enough evidence to support our claim. B, it is the probability that an individual falls in a certain range. C, it is an estimate of what values we think true
Proportion.
proportion lies between. D, it is a guess of where we think the sample proportion is.
Great, so I'll give you folks a minute or two to talk about this with your neighbors. So first of all, how do we find a confidence interval? How do you find a confidence interval? You take a sample. I get, in this case, proportion. I get a sample proportion. And then I do what? What do we do after that? I'd go a certain number of standard deviations this way, a certain number of standard deviations that way, and that would be my upper and lower limits. That would be my interval. What is that interval? Why am I taking that interval? What's it for?
That's your biggest part of your sample.
It's around my sample.
Yeah, but it's the, like, it's not the outlier. The whatever's outside of that sample would be the outliers, right? Whatever's outside of the normal standard deviations.
Those are my usual values.
Okay.
And that's for one item. These are to estimate. So when we do these for this one, we go a certain number of standard deviations this way and that way. This is an estimate. Estimate of what?
Where the parameter really is.
Where the parameter really is. What's the parameter is, it's for the whole population, where the true proportion or mean, in this case it would be a, which one, proportion or mean? Where the true proportion for the whole population really lies. So, I was checking to see if we have enough evidence. So what Dia pointed out was she said, it's not confidence level, it's called confidence interval. Confidence interval is the actual numbers, here to here. Confidence level would be a probability like 95% or 90%. So it's not that, it's the interval itself. So we were checking to see if we have enough evidence to support our claim. That's not true, because what's up with evidence and claim? Is that for a confidence interval?
No, it's for a hypothesis test.
Yeah, this is for a test. So it's not that one. Everybody follow that? The second one, it's a probability that an individual falls in a certain range. Two problems with that one. It's the probability. The probability would be the 95% or the 90%. That's the confidence level, not the interval. Does everyone see the difference? Second thing is, we're not talking about one individual. We're talking about, remember this is all relates back to the mean of the means, right? Proportions is the whole population, not just one person. Does that sort of make sense to folks? So this is not the probability that an individual falls in the range, it would be the probability that the whole population proportion would fall in that range. So it's not the second one. Second one's about it's not about individuals. Does that everyone kind of follow that? So it's never an individual. It's an estimate of what we think what values we think the true proportion lies between.
That's right, I guess.
Yep. Because D, is it a guess of where we think the sample proportion is? Is it a guess of where we think the sample proportion is? The sample proportion is smack dab in the middle, folks. We took the sample proportion and then we went so many standard deviations that way and that way. The sample proportion is not in this range. The sample proportion is in the middle of that range. So we used it to make the range. We don't need to estimate the sample. We know the sample. We want to estimate the parameter, the population proportion. So it looks like this is going to be a tough one. So everybody think about this one. We'll go over that one again, a similar problem like that next class to give people more practice with it, because I think we need more practice with this one, it seems like. All right, number 6. Devin, go ahead.
You conduct a hypothesis test with alpha equals 0.5 and get a p-value of 0.831. If you took a larger
0.081.
0.0831. If you took a larger sample and your sample proportion remained the same, your p-value would increase, decrease, or stay the same.
What do folks think? I take, so do I have some evidence? Does everyone see that? So if I have a p-value of 0.0831, that's some evidence. Does everybody follow? It's not enough evidence. How much evidence do I need? My alpha needs to be what? 0.05 or less. 0.0831 is some evidence, but not enough evidence. Does everyone sort of see that? If my p-value was 63%, that would not be evidence. That would be no evidence. Let me show you what I mean. Here's my, right, this is 0.05. This is where I want to be, over here. Where I was is here, where this portion here is 0.083. That's some evidence, right? I'm close to here, but I'm not beyond it. If I was here, that's a little bit of evidence, not much. If I'm over here, it's definitely not evidence. In fact, it'd be evidence the opposite way. Does that sort of make sense for folks? So over here, my p-value is like greater than 50%. Remember we saw that one time when we had the superintendent who thought her students scored lower than average, but instead they scored higher than average? So 0.083 is some evidence. It's less than 10%, it's less than 15%, but it's not enough evidence. So one thing we can do is take a larger sample. If we take a larger sample and everything else remains the same, that a larger sample, if we ask more people, should that give us more evidence or less evidence? More evidence. The more people you ask, the more evidence you have. A sample of 10, not such great evidence. A sample of 1,000, really good. Should give you a much stronger picture. Assuming that your initial findings led to it being sort of like this. So if you have some evidence, a larger sample will give you more evidence. Is that sort of making sense for folks? So this should be more evidence. All right, so then, with your neighbors, 15 seconds, is more evidence means that your p-value increases, decreases, or stays the same?
Decreases. Decrease.
What do you think?
Decrease.
Yep, decrease. Your alpha gets smaller, that gives you more evidence. Okay, should we go back through this one next class also?
If your alpha gets smaller.
Right? Yep, smaller alpha. Remember, sorry, not your alpha. I'm so sorry. The p-value gets smaller. Oh, did I say alpha earlier?
Just the last
Just
part.
the
That's
last
why I
Okay.
had to
Yeah, if your
notify.
p-value gets smaller.
Yeah.
Thank you for fixing that. Remember, when your p-value is low, H naught must go. You kick it out.
What was that again?
When p-value is low, H naught must go. P-value is low, H naught must go. All right. Here's a nice long one.
Yeah. It's the same one.
Yeah, you can just read it off the paper.
Interpret the level of significance in the context of the study. You're conducting a study to see if the proportion of voters who prefer the Democratic candidate is significantly different than 52% at a level of significance of alpha at 0.05.
Okay, so which one does that mean? The level what's my level of significance? 0.05, great. So which one of these describes that alpha 0.05? Go ahead. A?
Me?
Yes.
If the population proportion of voters who prefer the Democratic candidate is 52%, and if a sample of 204 voters are surveyed, then there would be a 5% chance that we would end up falsely concluding that the proportion of voters who prefer the Democratic candidate is different than 52%.
So if the proportion of voters who prefer the candidate is 52%. So if the proportion is 52%, that means if H naught is what? False or true? So H naught is always equals. So what symbol is the symbol for equal? Or so equals goes along with what words? Same. Okay. So is it saying that the proportion is the same as 52% or somehow different than 52%?
Same.
Same. Is 52% means the same as 52%. Are folks seeing that?
Yeah.
Is 50%, that means equals 0.52. That's H naught. So everyone, that means that H naught is true. If H naught is true, that's what this is saying. If the proportion is 52%. If P equals 0.52, then there would be a 5% chance of the time we would falsely conclude that it is different. Reject H naught. Okay, so that's what the first one's saying. That we would conclude that it's different. Then we reject H naught. Is that okay? So is that true? If my alpha is 0.05, then 5% of the time we reject H naught. So think back to those okay, so let's take a look at B. This is confusing. We'll go back to B. We'll go into B. Let's take a look at B. There's a 5% chance that the proportion of voters who prefer the Democratic candidate is different than 52%. Is that true or false? False. I don't know what the percentage, what the probability is that they're different. It could be, let's see, for all I know, it could be 63%. It could be totally different. I have no idea. Does that everyone kind of understand what we're saying? You don't know what the chance is that the portion of voters, whether they're different than 52% or not. You have no clue. How can we possibly know what that probability is? Right? It's either the different, or it's either different or the same. So it's either 100% or 0%, really. Okay, so let's take a look at C. If the proportion of voters who prefer the Democratic candidate is different than 52%, so we're saying that this is H naught is false. Is everybody okay with that part? All right, so it's saying that P is not 0.52. If this is true, then there's a 5% chance we would falsely conclude that the proportion of voters who prefer the Democratic candidate is equal to 52%. So then there's a 5% chance we would say it's equal. We would not reject H naught. So this goes back to, yeah.
So is the only difference between A and C
Uh-huh.
that A is you're looking at the population of proportion of voters and C
Nope.
is the proportion of voters?
Nope, they're both proportions. They're both the proportion. They're both saying nope, the first one's saying if H naught's true, 5% chance we reject H naught. This one's saying if H naught is false, then there's a 5% chance we would not reject H naught. Do you see the difference?
No.
Okay, so this one says, the top one says if the proportion is 52%, so in other words, if P is equal to 52%.
Oh, okay, I see it is indifferent.
Whereas this one is saying if the proportion is different than 52%.
So the difference is indifferent. So,
Yeah.
Okay, I see that.
So yeah, so the first one is saying assuming that P equals 0.52. The second one says is saying assuming that P is not equal to 0.52.
The language on these could be better.
Yeah, I know. I try to make it as clean as I could. It's hard.
I know, just
So basically we're making a mistake, right? If H naught's false, then we should reject H naught, and we don't. That's C. A is if H naught is true, but we reject H naught.
okay.
So which one is alpha? They're both errors. One's a type 1 error, the other one's a type 2 error, if you think back to your notes on that one.
So let's see.
So maybe we'll give you folks a couple minutes to discuss it. Yeah, 8A notes, page 55 of your notes. Talks about this, and then there are which one's your type A, which one's your type, type 1 and type 2. And there's a little bit of talk about that. All right, so which one is this incidentally? Is this type 1 or type 2? Okay, so I guess the question is, we want to know what alpha is, correct?
Yeah.
So situation A is H naught's true. Okay, so figure out which one of these is type 1 and type 2. One of them is type 1, one of them is type 2. Let's start with that. Alright, so if H naught's false, we should reject H naught. Does everyone kind of follow me? But we don't. The top one is H naught's true. If H naught's true, we should not reject H naught. But we do. Right, so one of them is type type 1, and the other one's type 2. Figure out which one's which. Looking at your notes, looking at this right here, which one's which?
Oh, just now. I was going to tell you, and then you started talking. Like, when you started pointing at
The pieces. So, type 1, that's A, right? The null hypothesis is true, but we reject it. And then this is situation C, where it's H naught's false, but we fail to reject it, exactly. So this is situation A, and this is situation B. But we want to know which one is alpha, right? So one of these has a probability alpha of occurring, type 1 or type 2. That's the question. So did anybody get further in the notes to find that? That's this one, type 1 error. It's when alpha percent of the time, so 95% of the time we get something that's normal. Remember when way back in the beginning of the semester when I had you folks all flip a coin 100 times and a few people, one person or two people got 59 heads or more? And those people would write a paper and get published. And then people try to reproduce that and they can't because it's not that the mean really is different, it's just that you got a weird result. That's going to happen alpha of the time, your significance level. So type 1 error will happen alpha of the time. It's when you get lucky and have an unusual sample. So you reject H naught when you shouldn't. When you should not. Shouldn't. And this happens alpha percent of the time, alpha of the time. That's why if we're talking about convicting someone of murder, you need to have a really small alpha. It should not happen randomly very often at all. Does everyone kind of follow me? So you need to have a lot of evidence. Your alpha should be like 0.01 or 0.001. Yes?
How do they decide the confidence level? Do they just like pick, or is there a mathematical?
It's not a mathematical. It's depending upon the situation. It's a great question. So if I want to know about whether the weights of the average weight of men should be changed so we can make sure that we're safe for elevators and lifeboats and things like that, I want to be really sure. So I'm going to have a really small alpha, a really small amount of error of this type 1 error. Does that kind of make sense? My alpha should be, the smaller your alpha, the more certain you are that you're correct. I want to have a 99% confidence interval. I want to have a small alpha. If I'm convicting someone of murder, I want to have it be 1 out of 1,000 times or 1 out of 10,000 times. Right? So I want my alpha to be 0.0001 maybe. Really small alpha. If it's something like I want to see if our class is better than their class. Maybe I only need 10% alpha. Right? That's a low stakes situation. Right? Maybe the winner buys the loser dinner. Then maybe you only need a 20%, 20% alpha, something low stakes like that. But if it's something, depends upon how sure you want to be and kind of how high the stakes are. And that depends entirely upon the situation that's going on. Good question. All right, so that leads us back to our original question, which was, which one of these was true? Which one was it where H naught's true?
Is it A?
Yep, A.
Is the other way to think of this is because in the question it says they're significantly different. It's not giving me is it more than or less than? So wouldn't there always be H naught is equal to?
No. That's different. Just tells you where your H1 is. Whether
Right.
H1 is not equal to or equal to.
That's what I meant.
But
so-
either one could be true, right? So if it's different, that means that either H1's true or H naught's true.
Okay.
If I'd said greater than, then I'd have to say greater than
H1.
here.
Right. Okay.
I'd have to make this H1.
All right.
Yeah. But I like the fact you're thinking about that. That's awesome. And thinking deeply and making sure you understand it, just like an expert student would do. Well done. Expert students in the making right here.
Yeah.
Okay. Number 8. Issa?
Suppose two more studies are conducted on this issue. Both studies find 45% of warm state households sampled own a dog, compared to 39% of cold state households. But study C consists of 100 households in each group, whereas study D consists of 40 households of each group. Which study would provide stronger evidence that there is a genuine difference in warm and cold states on this issue?
Great. So that's a good question. 2 studies are conducted to see if warm houses versus cold households own more, own a dog, or to see if there's a difference between dog owners in cold states versus warm states. We take 2 samples. They both show 45% versus 39%, comparing 2 samples. Everybody with me? 2 proportions, warm and cold, 45%, 45%, 39%. Which one gives you stronger evidence? The one with 100 samples or the one with 40 samples? 100. Does that make sense? Or sorry, sample size of 100 versus sample size of 100. Yep. The larger one. All right, good. Excellent. Let's take a break. We already did this one. If you did not do this one, then check back the video from last class, the end of last class.